Some of you may be aware that over the last year we've been playing around with the packet radio here, and we've set up the packet node here in the shack. So I thought I'd just say a little bit about what packet radio is, deal with it, how it works, and so after that we may have some time to do a demonstration afterwards. So packet radio is one of the many digital modes that we have on amateur radio. One thing about packet radio is that we take the information we want to exchange and communicate, and we break it up into small bite-sized chunks. And that's a bit different to other modes like PSK, where you key the mic and you start typing and you're sending a continual stream of data until you finish, and then you listen to the other person. So with packet radio, you actually break it up into small chunks, maybe up to a couple of hundred characters maybe, and then you transmit it over the air. So it generally only takes a fairly short time, and the advantage is if something goes wrong, then the other end can ask to retransmit that individual packet, so you don't need to retransmit the whole thing. And it also means that you've got multiple people on the frequency. They can share the frequency because you take turns at sending your own packet. And the packet radio system will make sure that when you send a packet, you can address it to a specific person. And so, for example, Ted and I could be having a conversation on the frequency, and meanwhile a couple of other guys could be having their conversation, and we won't interfere with each other on the screen. Of course, the more people you have sending packets, the more chance that two packets will be sent at the same time and cause a collision. So there is a limit to how many people you can actually have on a single frequency, but in principle you can actually share the frequency, so that makes it quite a nice mode. At the VHF and UHF frequencies, we generally operate at either 1200 baud, where we use audio frequency shift keying. So we've got two tones, I think they're 1200 Hertz, 2200 Hertz, and so you shift between those two tones to represent the binary ones and zeros as part of the mode. And we generally feed that audio into a FM transceiver, so it's audio frequency shift keying on top of FM. The problem with that is it's not a very efficient way to do it, so we can actually go a bit faster, 9600 baud. And what we do there is we take control of the radio's discriminator, and so then we do a more conventional type of frequency shift keying. So you're not doing it on top of FM, and it means that you can squeeze more throughput into a particular channel size. At HF frequencies, generally we operate a lot slower, 300 baud, because the conditions tend to be a lot noisier, static crashes and so forth. So that's 300 baud, and we use frequency shift keying. We use a closer spacing there. So I think, for example, it could be 1600, 1800 Hertz, so it's about 200 Hertz separation, whereas on the VHF it's a 1 kilohertz separation. So the tones are a bit close together, and it's a bit slower. What it also means is that we want to keep the packet sizes shorter on HF, because the chance of being wiped out by a static crash becomes a much higher chance that the longer you let the packet go on. So try and keep the packet short, and hopefully you can send them in between the static crashes. So this is the overall high-level structure of what a packet looks like. We generally have a bit of a flag at the start. Well, before that even, we send a bit of a synchronisation pattern to let the radio at the other end know that there's a packet that is about to start. And then the flag, which has 0610, that says, right, the packet's now starting, the business part of it. So we then send a header, which I'll talk in a bit more detail on the next slide. We send a payload, which is the information we want to send. So it could be, you know, "G'day Ted," or some text like that, or it could be other things. It could be an APRS position report, something like that. So we can put all sorts of things in there. Then we've got this checksum, which is it's a 2-byte field that you can calculate the you can use a formula to calculate a checksum value by combining all the information that's come before, and you compare it with this checksum byte here. And if they're different, it means that some of the information back here must have been changed. So if you detect that there's some problem with the packet, then what we do is we throw that packet away because it's been corrupted in some way, and so we can't trust anything about it. So packets which are corrupted always get thrown away. Yep.
That checksum and the formula that it uses, is it able to tell where it is, or it just tells that there's been a bad bit somewhere?
Yeah, it only detects that there has been...
What if you get 2 bad bits? Does it revert round and say it's okay?
Still wrong checksum.
It still gives you wrong? Okay.
Yeah, it depends. I must admit I can't quite remember the exact algorithm they use here, but there could be some situation where there's a particular pattern of bits get corrupted and it will match the checksum. That would be an extremely rare event. So generally, if there is any problem, and remember often the sort of corruption we get, if we get 1 bit corrupt, that there'd probably be a sequence of them, a stream of them, all corrupt at the same time. So the static crash is wiped out of the packet.
It's a 16-bit checksum, isn't it?
I think it is, yeah. So once it's finished, we then have another flag to indicate that the packet is complete. So yeah, the packet will be dropped, and so with packet radio, depending what type of packet we're sending, we may do something about that or not. So we can recover from that if it does happen. So a typical packet radio station, on the left is a more traditional type. We have a PC. Probably when packet first started out, it wasn't as fancy as that. It might have been a Commodore 64 in the VIC-20, I think.
Micro B.
So it could have been any of these very low-powered machines. And then they would connect via a serial cable to something called a TNC, which is a type of modem. And so here's an example of one. So we have some connections on the back. We have a serial cable that goes to the computer. So on the computer we just need to run a simple terminal program, Hyperterm or something like that. Then these TNCs have another connector on the back which plugs into the radio. And so it takes the information supplied over the serial cable, and then it converts it into these FSK tones that get fed into a radio. And so that's what this cable is here. Then once you provide tones to radio, you also need to decide whether the radio should transmit or not. So a couple of ways you can do that is you can have a separate line here that will push the talk on the radio. Or you can also use Vox on the radio as well. That tends to work quite well in most cases. So one way or the other, the radio gets triggered, sends a packet up to a bulletin board or another packet station. These days, though, because our computers are a lot more powerful, we don't necessarily need to use a dedicated piece of TNC hardware like that. We can actually run some software on the PC that does that modulation, and it produces FSK tones out its sound card. So you can actually avoid using a TNC altogether and just plug the radio into the sound card on your computer, or use one of those sound card interfaces like SignalLink or RigBlaster, or one of those type of interfaces to connect. So that's basically how I first got into packet radio. Was I had a PC, I ran some software, but I had a SignalLink interface, and it just went into my radio, and I could use the box on the radio to trigger the transmitter. Okay. So, packet radio, I said we break the information up into bite-sized pieces, and what we do is we put them into something called an AX25 frame. So the protocol that describes packet radio is called AX25. Now, if any of you work in the networking industry, you may have heard of X25. So AX25 is basically an adaptation of the X25 protocol, and they've just made a couple of small changes to make it more appropriate to amateur radio. So, for example, the addresses in packet radio are actually call signs, so it makes sense, whereas in X25 they're just some arbitrary numbers. There's three different types of frames we can see. We can have information frame as an I, we can have an unnumbered frame as a U, and we can have some supervisory frames. So I'm going to focus just on the first two. iframes have these things called sequence numbers. So they're little 3-bit numbers, which basically make sure when I send the packet, I give it a sequence number so that at the other ends they know what order the packets need to go in. So if the packets arrive in a different order to what I sent them for some reason, then that can be sorted out at the other end. Also, if a packet's missing, you can see the sequence number suddenly skips one. So you can then send a request back to the sending station to say, hey, I didn't get this packet in the middle. Can you resend it for me? So
it's only 3 bits though.
It's only 3 bits. So what that means is that if you want to send, what you can do is you can send several packets in one go and then get them acknowledged in one hit. But there's a limit to how many packets you can actually queue up. So you can't have more than, is it 7 or 8 packets actually on the air at once. So that is a bit of a limitation there. But this whole concept is, it's a bit like on the internet you've got this protocol called TCP. It's used for web browsing and telnetting to places and all sorts of things. So here at TCP, you're establishing a connection with the other end first, and then you're sending packets and using these sequence numbers to make sure that they arrive in the correct order. If any are missing, then they'll be retransmitted. So this actually provides a reliable session, and it means that if there's problems with the channel, the sending station will keep on resending until the information is received correctly at the other end. So it's a reliable method of communication. The other type of frames, unnumbered, don't have these sequence numbers. And so when we send an unnumbered frame, it's outside the context of an existing connection. So it means that there may be some connections on air, but this is something outside those. So you can use a U frame, for example, to request to set up a new connection. Or in the case of U iframes, these are unnumbered information frames. You can actually use these frames to transmit information. So the information won't be retransmitted if it's lost, but you don't need to set up a connection first. And one application where this fits really well is something called APRS, which we'll talk a bit about later. It's similar to, on the internet, I mentioned TCP was similar to the iframes. UDP is again a connectionless datagram on the internet. So often it's used for voice applications, for example, where if you lose information, then it's not worth trying to get it resent. Just forget it and get the next bit. So if you lose a few packets with a voice stream, then generally it's not going to impact the quality too much. But with voice, you don't want to be waiting around for things to be retransmitted, because that then creates a big delay, and it's very difficult to have a telephone call when there's a long delay on the line. So a couple of other features I just want to highlight. We have the addressing field, which says where the packet's from and where it's going to. So the destination call sign and the source, the destination call sign and the source or the sender's call sign are there. So this packet would be going from VK2RQ to VK2DOT. We also have this extra field called an SSID, which you may have seen before, where you have a call sign dash and then a number from 0 up to 15. So what this means is that when we have a connection, the connection is defined by these 4 fields. So if I want to have a second connection to VK2DOT, I need to connect to a different SSID in order for those connections to run at the same time. And the other thing is that VK2DOT, that's our mate Rod up on the Central Coast, he may have a number of services running on his station. So I may want to connect to his bulletin board, or I might want to connect to his packet cluster, or some other services that he's running up there. So you can use the SSID to indicate to the remote end which service you actually want to connect to.
How many bits is it?
It's a 1 byte field, so 4 of those bits are used for the SSID, which means you can go from 0 to 15. And then the other bits are used for some other things. So for example, we can actually extend this address field. These ones are optional. We can use something called a digipeater. And so we put in the call sign of the digipeater and the SSID. So with a packet set up like this, VK2RQ, what I would do is I would send my packet first towards this VK2NB-7 station, which would then retransmit it to VK2DOT. Once a digipeater has been used, once the digipeater has retransmitted it, it will then change some of the bits in this SSID field to indicate that the packets traverse that digipeater already. So we'll talk a bit more about digipeaters later, but you can actually have several of these digipeaters, and so they need to be followed in the correct order. So the system needs to know which digipeaters have already done their job, and so whose turn is it next to do the digipeating.
Is it to stop like permanent echo or something?
Well, in the case of APRS, it is used in that way. Yeah, the idea is we're forcing a particular route. So if a digipeater later in the chain can hear the packet, but it's not that guy's turn yet, so we can actually force it to go via an intermediate one. So it could be, for example, between this station and that one, we can hear each other, but the quality is a bit bad. It's more reliable if we've got this intermediate one, so I can force it to go through a specific intermediate station. So what that means is, if I send this and the bit here indicates that the packet hasn't been digipeated yet, then even if Rod hears it, he'll ignore it because it's addressed to him, but he'll ignore it because it's meant to go to the digipeater first. And then
each digipeater only has to know where it has to go to next.
Well, the digipeater will receive if it hears a packet addressed to itself, what it will do is it will retransmit it. And then so hopefully the next digipeater you put in the list, or the final station, will be able to hear that digipeater. So the digipeater doesn't know whether you actually hear the packet or not. It just hears something and resends it.
Can you have more than one destination station?
Or
Yeah, it's good point, like a broadcast.
So
you'd be using the
So in the case of iframes, no, because we're establishing a connection between 2 specific stations, and so we're just setting up an individual connection there. In the case of your iframes, we're just sending them out on the air. So as you'll see in some cases, we won't even bother putting a valid call sign in the destination because we really don't care. Anyone who hears the packet can want them to do their thing. And so APRS is an example of an application where you use UI frames, and that's a single point to multi-point. With iframes, if you wanted to have something like a multi-way chat, there are ways to do that, which I'll mention.
Matt, does the iframe have like an ACK packet that it sends back?
It does. So that's another key difference I didn't put on the slide. But when you send an iframe, then you must get an acknowledgement back from the other station. If you don't receive that acknowledgement, you send the packet again because you assume that the first packet must have been lost, or maybe his answer was lost.
Does that come from the digipeater or from the end?
Okay, that's a good question. I've got a slide on that later on, but in the case of digipeater, it's end-to-end. So
a packet has to make it all the way through, and a knowledge has to come all the way back through 8 digipeters before you can send the next packet?
Yes.
Oh, baby.
And it's simple. It just comes out R1 or R2 for the packet.
So if we lose it on the middle, say there's 4 digipeters and we lose it halfway, the digipeters aren't smart enough to say retransmit.
That's right. So that's a limitation of digipeters, but we do have a solution. So hams are a resourceful bunch, and I'll show you what we can do about that. Okay. So what are some of the things that we actually do packet for? Well, we've said that we can establish connections between stations and exchange information, or we can send out an unnumbered frame that people can pick up with we can broadcast some information basically. One of the first or most basic applications is simple keyboard to keyboard chat. So if you tell your TNC, I want to connect to such and such a station, and you may tell it to do it directly, or you may ask for it to go via some digipeters or something. At the other ends, there'll be some indication that there's a station coming in to connect, and it'll establish a connection. And then you can start typing. You'll also have a blank screen. So, for example, I can type, "Hi Rod, are you there?" And then he'll type something back, "Yep, what's up?" And so these messages get broken into pieces, transmitted over that link, acknowledged to make sure that it's reliably received, the checksum is calculated, so you can get a reliable representation of what was sent from both sides. So it's okay for sort of short interactive messaging. One of the problems with packet radio you learn pretty quickly is often you connect to a station at the other end and discover there's no one there. So a lot of people leave their packet stations running, but they don't actively monitor the screen. So if the other guy's there, this can be a good way just to have a quick conversation about something. But if the guy's not there, there are actually better ways to communicate via packet radio.
Cross him off the Christmas card list.
That'd be faster too.
And I'll talk about ways we can use to extend the range, so you don't necessarily have to be in earshot of the other station. There are ways to. Okay, so coming back to, is it Lon? Like your question, if we have multiple stations wanting to chat with each other, on the packet we have these things called chat servers running, which I don't know if you've ever played around with this internet relay chat on the internet, but it works in a very similar way. So you, from your packet station, you connect to a station and they'll have a chat server running, listening on one of their SSIDs. So you connect to the call sign of that station with that specific SSID, and it will bring you into into the chat server. So what it means is that anyone connected to that chat server, if someone types on their keyboard, everyone else will see what has been typed. The problem with that is it can be a bit confusing. So you can actually create these things called channels. Here's an example of the channel number here. So you can, when you first connect, you probably arrive in chat room number 1000, and then if you want to branch off and have a private meeting, or just a small group meeting, and not be interfered with the general chit chat that's happening on the chat server, you can actually move to a different chat room. As well as having a single server, you can also have multiple chat servers which have links between them. And so this is again similar to IRC on the internet. So what it means is that if I type something on my chat server, it will then resend it to everyone who's connected to that server, plus send it over to another server that's connected, and then broadcast the message to all their users as well. So you can actually have a cluster of these chat servers all interconnected. And if one chat server goes down, the local users are, well, I guess it's bad luck for them, but at least the rest of the network can still communicate.
So does the chat server address its packets to anyone, or are they UI frames so that everyone can
Because everyone who's connected to the chat server will have established a connection to that chat server, so it means that there'll be iframes between the chat server and that user. So if I type something, it'll go over my connection as a set of iframes, and then the chat server will have to send it to everyone else who's connected, again using iframes addressed to those specific stations.
So if there's 10 people on the one chat server, has it got and one person types something and it receives a packet from the one person and then transmits it to the other 9 users, has it got to wait for 9 frames to...
If all those users are accessing the chat server via the same frequency, then yes, you're going to have some congestion, I'd say. But remember that this chat server may have several TNCs and radios. We generally call those ports. So it could be that maybe there's a few users accessing via 2 meters on this frequency, and maybe Ted's connected in over HF, and maybe there's someone else connected over an internet link. There's actually ways that we can run packet radio over the internet as well. So, but you're right. That is I guess a limitation of that approach is that the frequency you'll be retransmitting multiple copies of the same message.
I suppose you might say it's similar to the echo link.
Yeah, in a way that's true as well. Yeah. So here's an example. I just connected to chat server. This is Rod's chat server up on the Central Coast, and so I was the only user on earlier today. So I didn't have anyone to talk to. I said hi Rod anyway, just to show that it works, and it has my call sign I connected from. So I connected from VK2RQ with SSID7. That's where I connected from, and I connected to .cht, which is an alias for VK2DOT-8. This is the SSID of his cat server. So I'll talk a bit about the aliases a bit later, which make it a bit easier sometimes to work out what the different things you need to connect to are. Okay, another application we can do is a bulletin board. And so I mentioned that with the keyboard-to-keyboard chat, if the guy's not sitting there, then you're not going to be able to send a message. So what you can do is you can send him a message that will be stored on the bulletin board system, and he can come and read that message later. So it's very similar to email. And another thing bulletin boards you can do is you can actually send a message not to a specific ham, but to basically you can flood it throughout the packet network, and you can either do that worldwide so everyone in the world can see your message, or you can restrict it to a region. So I could say I don't want it to go outside Australia. So they're called bulletins.
What's the backhaul for those? Is it internet or HF or something?
Backhaul.
It sounds like FidoNet from back in the day.
The backhaul is AX25.
Yeah.
So how are you going to transport the AX25? You can use RF links, you can use internet. You can even forget AX25 altogether and get the BBSs to use a lower level protocol like Telnet. So you don't even need to put it in H25. If you're both connected to the internet, you can just establish a Telnet connection, and then the TCP is doing that job of making sure you've got the reliable connectivity. So here's an example where I connected to Rod's BBS. So once I connected it, said, hello Matt. First time you connect, it'll ask for some basic details like what's your name, your location, that type of thing, so it knows who you are. So it remembers that I'm Matt. So I'm on channel 16, a bulletin board. A lot of the time these bulletin boards are running on low power DOS machines, so they only had limited memory, could only support limited number of users. So the channels is just basically how many people were connected to the bulletin board at the same time. So here I'm connected. You can see I'm connected from VK2RQ -0. So the SSID was 0. In the packet world, often if you just have the call sign, that's the same as putting -0. So it's, often if it's -0, we don't bother writing it, but here it's actually written it explicitly. Date and time I connected, and it says, oh look, I've got one unread message. So it's a personal message, so it's not a bulletin board to everyone. N means it's new, and L is local, so it was locally generated. And you can see it was generated from this other guy, VK2RQ.
He's a pirate, isn't he?
No, he's legal.
Legit.
Still holding it.
Still got it. Mainly so I can play with packet stuff like this. I just got the renewal notice today, actually.
That's you with all your friends.
Yeah, so it's got a greeting. So the VK2RQ has actually got his own BBS. So what will happen is that normally this message will get forwarded to this guy's bulletin board. But I connected as soon as I sent this, so it hadn't had time to forward it on, which is why it indicates as new rather than a message that's already been forwarded. Okay.
Matt, I don't know if it's the right place to ask this right now, but if you know someone's packet address somewhere in the world, do you have to know the routing path to them, or can you just sort of chuck it out there and it wins its way?
So there's actually a service running on these bulletin boards. They communicate with each other. It's called white pages. So every time someone sends a message, then the white pages database on that bulletin board gets updated. And so when I sent this message as VK2ACL, Rod's bulletin board would say, aha, VK2ACL sent a message from my bulletin board. So therefore, I think maybe any messages that this guy sends should come to me. And so then what he'll do is he'll, every night, I think at midnight or something, he'll send out a message to all the bulletin boards he knows about, saying that, hey, this guy just sent a message from me, so you probably should direct messages towards me. Now, the way it's set up is it won't, the other bulletin boards won't immediately act on that, but if I send a few messages like that, it'll learn that, okay, this guy definitely seems to be sending a lot of messages from this bulletin board. Therefore, if anyone wants to talk to VK2ACL, send it to...
and that ripples around the world, sort of.
And it ripples around the world through this white pages database mechanism. Yeah, good question. Another great application for packet radio is the packet cluster, the DX cluster.
Oh yeah.
So this is used, hams connect to the DX cluster service, and they can send messages which basically get seen by everyone, and they can make these special types of messages here called spots. And so if I'm tuning around my radio, I hear some rare DX station. I work in myself first, obviously, before I tell anyone. But once I've got the contact in my log, I then go over to my packet station and I send a message here, which then everyone who's connected to the packet cluster can see. Okay, it would have my call sign if I entered the spot, frequency, the call sign of the DX station I found, some comment possibly, and the the time which it came in. So yeah, I've typed that message. Everyone who's connected to that DX cluster server will see that message. And like with the chat servers, I said you can have one chat server connected to another chat server, and so you can have a worldwide network of these things. Packet clusters work the same. So a particular DX cluster server can be connected to other DX cluster servers within that cluster. And so if I type on one server, it'll eventually get sent to all the users connected to all the servers that belong to that cluster that need to connect with each other. I think with the DX cluster, they've even got some links that carry spots between the different clusters as well. So they've even got inter-cluster links. One example is something called reverse beacon, which has these Morse code skimmers that are listening to large slabs of airspace. And every time they hear a station called CQ, they generate one of these spot messages. And so you can actually have those spot messages coming into your cluster here via one of those intercluster links. Apart from spots, there's some other information that is sent by these things which can be an advertisement from a person, or it could be the sunspot reports that you get from the WWV. So that's automatically generated. I think every hour they send out what the current sunspot count and A index, K index, all that good information. And through, I can use commands and things to filter out what I want to see. So, for example, I may not care what some guy in America is hearing. I only want to see what guys in Australia are hearing. So you can actually define filters. I can type some commands that will restrict the number of spots that get presented to me, so then I only see things that are really interesting for me. Another thing is that the frequency. If the frequency is outside the 40 metre CW band, maybe I don't want to care about it. I'm only interested in CW contacts on 40 metres, so I can say that, you know, if it's between 7 meg and, what is it, 7045 or whatever the upper limit is, then it presents it. Okay. Oh, I guess the other thing I should mention is that a lot of these DX clusters, again, provide a telnet port. So if you're purely coming in over internet, you don't have to go to all the trouble of setting up AX25 connection. You can actually just come in with a telnet connection. And these days, that's probably how the majority of people actually access these clusters, is through telnet rather than packet radio or AX25. But yeah, the AX25 is still an option. APRS. So this is the automatic packet reporting system. Some people think it's the automatic position reporting system, but in actual fact, APRS is more than just position reports. It can also be information such as weather, bulletins about what's happening in the area. So we could have a bulletin advertising the lecture for this evening. Text messages, we can do a simple sort of SMS type of text message sort of facility. And of course, you know, position is the most common thing, and it may include speed and course heading, that type of thing. Could have telemetry, like we could have the digipeater in the main repeater hut monitoring the battery voltage, and if you know, reporting how much the batteries or the supply voltage currently is. So
yeah, it's great that they do that every second for
selected times there.
Yeah, so APRS is quite a flexible reporting mechanism. Now, like I said, you basically just want to send information out in the general area where you are. You don't want to address it to a specific person. So setting up a connection and then using iframes, that's not a good fit for APRS. That's why we use these unnumbered information frames, EUI frames. So they basically they go out and anyone who hears them will be able to decode the information. And then if you run a little application on your laptop which has a map, for example, you can take the coordinates that you're receiving and you can plot it up on the screen, and you can watch the cars drive around. And so that's just all happening over RF. There's no need for internet connectivity or anything. But it was actually found that some people were listening for APRS traffic in their local area, and they would actually report it onto the internet, and there'd be a big database on the internet which would a server which would collect all the APRS reports that people have heard. And so that's quite a common thing, is people will log all that information that they hear onto the internet. And that then becomes very powerful, because it means that you don't necessarily have to be within hearing range of, within RF range of the station making the report. You could be on the other side of the world, and you couldn't go to this database on the internet and see what stations in Australia are picking up. So that's it's quite a powerful thing. Because the destination call sign doesn't make sense in the case of APRS, because you're really just sending it out as a general broadcast, not to any specific station. Generally, the destination call sign is first two characters are AP for APRS, and then 4 more characters which are supposed to indicate the brand of TNC you've got and the version number. But in actual fact, what you put in that field doesn't matter at all. And you can see down here I've actually got some real APRS packets that were picked up. Here's the destination call sign. So he's used S3T2R6. So he's not using the right format here, but
we should report it.
Yeah, I don't know. I don't know what that's meant to mean. It may have some significance, but technically it really doesn't matter. You can put whatever you like in the destination field. So these aren't the actual packets themselves, but it's basically they've extracted a lot of the information out of the packet and presented it in a human readable form. So this is coming from Mr. VK2RQ, who actually just lives up the road from me, and he's probably 5 o'clock, so he's probably driving home from work, I'd say.
Baby, yeah.
So here we have the digipeater path. Now, one of the things I should mention about digipeaters, as I said before, you have to specify exactly which digipeaters you want the packet to go through. Now, in the case of APRS, you don't really care which digipeater hears you. You want digipeaters to repeat your packet regardless. So on APRS, they have a bit of a cheat, and they give all the digipeaters on the network the same call sign. And it's generally something like wide 1 or wide 2. So we use a wide 1 call sign for something called a fill-in digipeater, which is just, it's a bit like the little digipeater, fill-in digipeater we've got up there, where it's not in a particularly brilliant location, but it just provides some local coverage around here, so that if someone can't access one of the main, what we call I-gates, and I-gates are these stations that are listening for packets and reporting them on the internet. So if you can't reach one of those, one of these fill-in digipeaters, maybe nearby, it can retransmit, and then it'll generally be set up so that it's in range of one of these I-gates. So, so when we send the packet, we need to define our digipeater path. And we use, we generally mention that we want a wide 1, which means if there's a fill-in digipeater, we want to use it. And then we put wide 2. That means that if there's a wider area digipeater, then it can be used as well. There's some applications we wouldn't want to indicate fill-in digipeater, so we know we live within a particular range. So for example, from my place I can easily get to the main iGate up at the repeater hut. So for me at home, if my station is just sending APRS packets, there's no point in me defining a fill-in digipeater, because if there are any fill-in digipeters nearby my house, they'll retransmit the packets and it's just useless traffic. Because I know that the main iGate will probably hear me first time. So these are call signs you use on the digipeaters. Then the SSID, they use that as a sort of a hop counter. So you can see here we've got the wide 1-1. What that means is that once a fill-in digipeater retransmits the packet, it will then decrease this down to 0. And in fact it will mark that digipeater as having been used. So it sets the H bit. And so what that means is that if there are any other fill-in digipeters, they won't try to retransmit that packet. So it limits the amount of APRS traffic that we have in the network. Then generally we have something like a wide 2-1. So if one of these wide area digipeaters that's up on the big hill or something retransmits the packet, again it will decrease that 1. So this packet here, it could potentially have 2 hops. It could go through a fill-in, and then it could go through one wide area digipeater before it arrives in the iGate. Now, because we've got wide 1-1 and wide 2-1, what that means is that this iGate here, VK2BEN, has actually heard the packet directly. So it actually, if the packet did get digipeated, then the iGate didn't need it. It just reported it on the internet straight away. Down here we can see this wide 1, the fill-in digipeater has been used. Normally a digipeater should mention, it should actually replace or insert in the path its own call sign, which it hasn't done. So some of the older APRS systems, like this one for example, they don't insert their call sign in the path, which it's sort of an older
Is that
version.
what the top line has done? Is that why it's got AMW?
Yeah.
Yeah, so that's why I chose to include this line. So here's an example where it's inserted itself, and we don't know whether that was a fill-in, or more likely it was it's a wide area digipeater, and so probably the guy in his path had wide 2-2 when he first sent the packet. So this guy digipeated it, put his call sign in, marked himself as having digipeated it, that's what the SAR means, and then he would decrease the SSID. So potentially one more top-level digipeater could resend it, but then it got picked up by our iGate at the repeater hut.
Matt, does it matter which here's it first? Like, does it whether you've got wide 1-1 and wide 2-1? Does it matter if, say, a wide, like a large area digi, if that hears it first, does that not do anything until he's one of those fill-in digits? Or
So with APRS, they cheat a bit, and even if the wide 1-1 hasn't been indicated as being used, if a wide area one picks it up, it will digipeat it. So even though there's no fill-in used, so that is a bit of a departure from the strict standard of packet.
So there's no priority on either one.
That's right. There's no priority.
You got any explanation on whether stop using gate?
Gate. So gate has a specific meaning, I think. It's more for the HF, if you're doing APRS on HF. And what it means is you want any packets addressed to a gate station to be retransmitted on the VHF network.
Mm-hmm.
So, I don't know, is there a good reason to...
That's sort of discontinued it.
Yeah, I must admit I haven't checked the latest status of that, but that's I believe what the gate means. And there's also something called a no gate, which you can put where it will not be retransmitted. I think there's even one called RF only, where it will not reported on the internet. So if you don't want your packets being reported on the internet, you can actually put that in the list as well. Whether people honour it or not, that's another discussion. So that's the format here, and then here is the actual information that's sent. So this is the actual position report. So the first character here indicates what type of information it is. So a little backtick thing means it's a position report in compressed format. So then we have the, which comes first? Is it the latitude first? Then we have a slash, and then the longitude. And the slash here indicates the symbol, how it will appear on the screen when someone calls up an APRS screen. So, like I said, you can have all sorts of different information in that field there, and you can even put a comment. So here it is said tiny tracker 3 on 2 metres. So that's obviously his car as he's coming home from work. He's got little tiny tracker 3 on the 2 metre APRS frequency. Okay. So yeah, the APRS IS, there's actually a number of different servers on the internet. And you've got sort of the main core ones, and then you've got these second tier servers that are the ones that these iGates should connect to. They shouldn't go directly to the core guys, and they all replicate information between each other. So if one of these servers goes down, then another server will be available to handle the traffic. Okay. All right. So if we can't hear each other directly via the RF channel, then how can we extend the range of our station if the guy we want to talk to is out of our range? So there's different methods. The first basic one is digipeating. And it's very simple. You have a special field in the header, which I showed you before. So the packet gets addressed to the digipeater, and if the digipeater sees itself in that list as the next digipeater to handle a packet, it will retransmit it, and you can have more than one digipeater in the path. The packet will be presented at the far end station, and then that far end station needs to acknowledge that packet, so it will send back the acknowledgement will get digipeated, and then the acknowledgement will get digipeated there. Now, what happens here if that acknowledgement is lost? Then what it means is that this guy never receives an acknowledgement, so he has to resend the packet. It'll get digipeated again, digipeated. Now, that means that each one of these hops has to succeed in order for that packet to be, in order for this station to move on to the next packet. So it generates a lot of traffic on the frequency, and each hop has a certain chance that the packet will get clobbered. And so the more hops you put in with digipeaters, then the lower and lower the chance becomes that you'll be able to successfully make this end-to-end send the packet and receive the acknowledgement. So with digipeaters, in practice, you probably don't really want to use more than about 2 digipeaters. I mean 3, if conditions are okay, maybe, but beyond that, forget it. So that's a real limitation of the system. So what can we do about it? Well, before we get on to that, what can we do about it? Here's another thing we can do. We can have something called a data regenerator, and this is very much like a repeater. It's probably listens on an input frequency and then has output on some offset frequency. So it'll receive the packet. It will then make a new copy of the packet with nice fresh tones, and then resend that same packet. Now, in this case, with the data regenerator, it basically, if it hears any packet at all, it will resend that whatever it hears on its output frequency. So it doesn't look at headers, it doesn't care where the packet's addressed to. If it hears something on its input, it will regenerate that on its output. So that means that this guy actually doesn't really have a call sign or anything like that. He doesn't modify the headers in any way. So from these end users' perspective, it's really like a direct connection. But in actual fact, you've got this intermediate station, basically relaying your packets back and forth. So we do actually have an example of that. VK2RQ, that's the Central Coast Amateur Radio Club. Up at Summersby, they've got one of these data regenerators on 70 centimetres. So you'll hear packets from that on this output frequency, 439.150. And if you want to send to it, you need to send it with a -5 megahertz offset. So if you're going to use this data regenerator, you need to set offset on your radio similar to as if you were using a repeater. With this, you've got a similar problem with digipeaters. So if you lose that packet, you need to wait for things to time out and retransmit. But that can be.
Can you set the timeout?
On the station here, yes.
Yeah. And what's typical? What would you normally use?
It depends on the specifics of the channel. Normally, sort of a couple of seconds, sort of thing. And then there's actually a number of timers in this AX25 protocol, which I haven't gone through because it's a bit tedious, I guess. I did mention the standard on one of the earlier slides. But there are certain key parameters that are important. So, for example, the maximum length of the packet you're going to send. So how big or how small are these bite-sized pieces you're going to cut your message up into. And on HF, you want really maximum 40 characters in a packet. Any longer than that, it just goes on too long and it's going to get squashed by a static crash or something. On VHF, you can often go a bit longer, maybe 100 or even up to 200 characters in the packet. So that's one, and then there's the retry timeout. So there's a number of different parameters that do need to be optimised, and it does depend a bit on the type of link. Is it HF link? Is it VHF? That sort of thing. If it's a good quality path, you can be a bit more aggressive. You can set a window, so you can say just go bang, 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 send 4 packets before you expect any acknowledgements back. Or if it's a lower quality link, you want to send a packet, wait for the acknowledgement, then send the next one. You don't want to be sending 4 packets and then half of them don't make it. Okay. So I mentioned that this problem of losing packets with digipeaters, long paths are not very practical. So they invented this thing called NetROM. And it's a bit different from a digipeater in that if I want to connect to this remote station, what I'll do is I will actually explicitly connect to this packet node here. And it's running this, it's this NetROM node. And so then I'll get a nice login prompt and I can type different commands. And one of the commands I'll type is connect to this next guy. Now, one of the advantages of this NetROM is that the different nodes are paying attention to what other nodes they can hear. And they basically send out an announcement that describes all the different packet nodes that they've heard about, that either they can reach directly or that they've heard someone else can reach. And so the network is sharing all this routing information. And it works quite similar to the RIP routing protocol on IP routers, if you've ever played around with IP routers. So it's a, what's it called? It's a vector. It's a vector, distance vector routing.
Oh yeah, OSPF and all those sort of things.
Yeah. It's not the OSPF one. It's
the shortest path first.
the RIP style of doing it. And each time it sends an announcement, it also has a quality value, so which degrades the more hops you've got, the quality value gets reduced. So that in the end, the network, each node in the network has a pretty good idea how to reach other nodes in the network. And the advantage of that is you don't actually have to specify an explicit path through the network. So I can, once I connect to one node, I can say I want to connect to this node here, and it will either go directly, or if it needs to go via other NetROM nodes, then it will do that, and I don't even need to know about it. So yeah, it's quite a big improvement. The other thing is that when we send a packet here, this node will immediately acknowledge it before it retransmits it here. And so it'll expect an acknowledgement. This one here will expect an acknowledgement from there. Now it's using my call sign here. I originally used VK2RQ-4. This node here will actually change the sender's call sign to a different SSID. And it does it by subtracting this 1 from 15 to work out the SSID here. So it will actually retransmit on my behalf using my call sign, but a different SSID. And then this one here will again do the same thing. So you can actually see the SSID changing from hop to hop. Once the packet gets right to the end, this station will acknowledge it to this node here. If this acknowledgement gets lost, these acknowledgements are already taken care of before, so it's just we send the packet here. If that acknowledgement gets lost, just retransmit here. So the acknowledgement is on a hop by hop basis. And so what that means is that the node will work much, much better than a digipeater. So if you've got a choice between using a node and using a digipeater, then generally the node is the better option.
The trouble is you're limited to what the CNC can do there.
That's true. So if you want to run a node, you need a fancier TNC that knows how to handle this NetROM. If you've got just a basic TNC that doesn't have any fancy feature like that, you can connect to another station that is running one of those fancy TNCs, or on their computer they're running some fancy software. And so then once you're connected to that station's node, then you can basically take full advantage of the facilities offered by that node.
The only problem with doing this is you're not actually, the ACK is fake. So when the packet's in flight, you've got an ACK on the sending station, but it doesn't actually mean that it's been received. Right?
Yes, that's right. So you receive an ACK, so you think that everything's
but it's still in flight.
What if this whole RF link is dodgy? So this station here isn't hearing that node at all.
Yeah.
Then I've already received my ACK, so I think everything's fine, but this node will keep on retransmitting. This station either won't hear it, or if it does reply and the reply gets lost. So basically the connection here will break.
Doesn't time out, or
it'll time out. And so that's one of the downsides of this NetROM protocol, is that sometimes things will suddenly seem to go into a black hole. And
there's no provision for the timeout to go all the way back.
Well, there is no ACK back.
No.
So you could create
no end-to-end acknowledgement anymore, because it's done on a hop-by-hop basis.
You can create a storm or something if one of the stations is there smashing out packets, and 3 hops down it's going nowhere. I guess you'd eventually give up, right? But if you were sending a large file...
What will happen is that, remember I said with these sequence numbers you have a maximum of, is it 7 or 8 packets in the queue?
Yeah.
So eventually this guy's queue will fill up if he keeps receiving packets. Then he'll have to send back a flow control.
A flow control, okay. That's smart enough.
It says, hey, stop,
okay.
I'm not ready to receive it anymore. And so that will actually quench that.
Very quickly.
This is where we're missing VK2TT at the moment, because his node into Queensland was good.
Yes.
But we haven't really got a good node into Queensland anymore.
That's okay. So
come on, Matt, get on.
So I mentioned a lot of this stuff is. I guess I'm talking about VHF, but HF as well. You can also have phone packet, and so on 40 meters, 10 a number of other guys get on, and myself and also Gerard VK2RQ have stations with ports on that frequency. And so, yeah, if the propagation's a bit tough up and down the coast, you can't quite get into Queensland, but there's a node in the middle, you can go through that node. Or if that guy, his TNC doesn't support NetROM for some reason, you can actually digipeat. That's another option as well. So yeah, the more stations there are on the network, then the more different things you can try. It gives you more options how you can try to reach the other end.
For the flow control, it just backtracks through the network, right? Like, does each NetROM mode hold a database of, like you know, IP at NATs, so it has a database of all the NAT connections. If this thing was to go RQ4 to RQ11 to RQ4, okay, that's no good, that buffer's full, I'll send a net flow back. It doesn't go back to the sending station, does it? It just goes to the preceding digi?
Here it's a hop by hop.
Yeah, so you basically have to go through and fill all of the caches up, yeah.
Yeah, that's right. Yeah, okay. So when I set up the station here, I tried very hard to make sure it was a node and not just a digipeater. So we have to thank Ted for donating the TNC to me for that project, and also Gerard VK2RQ donated the little EPROM chip. So I got one of those burners and managed to put on the special NetROM firmware. And so now that station we've got in the shack there is a proper NetROM node. It's not just a digipeater. So that's this is the reason why I tried very hard to make sure that was a node. Okay. One other option we've got to extend the range is we can actually take these AX25 frames and put them into IP packets on the internet. You can either put them directly into an IP packet, or you can put them into a UDP packet on the internet. And you can actually send that to a station at other side of the world or wherever. We'll then extract out the AX25 frame and then process it as a normal packet. So here you're actually doing packet radio using the internet as your transport channel rather than an RF link. But from the two stations' end perspective, the behaviour is the same. It's like the internet is some long distance RF channel.
Didn't this used to be a lot of this stuff was transported on satellites before it was popped over the net?
Yeah,
upload from Sydney and then they download in the States 30 minutes later.
Bulletin boards. So what you can do is, as the satellite runs over, you can establish a connection, quickly type a message that you probably would have prepared beforehand, I'd say, and keep it short. But yeah, you can actually leave a message on the BBS, and then as the satellite goes to the other side of the world, someone can pick the message off. So each satellite can be a physical transport as well. So the advantage of this is if you've got a packet network, for example in Europe, and another packet network in Australia, these separate islands, you can actually bridge those two together in one of these virtual channels, and you can use a tunnel over the internet, or some people call them a wormhole, because you sort of go into one station and somehow magically appear on the other side of the world, out the other station. So it allows the packet network to keep running even though not all the stations, there's no RF path between parts of the network. So here's a bit of a diagram of some of the packet infrastructure we have in the local area. So here I'm ignoring APRS because that's a whole other diagram. It's a lot bigger, a lot more complicated. But so this is talking about packet radio as in what you would use for a BBS or DX cluster or chat, that type of thing. So we've got the station here in the shack, VK2NB-7, there's a node. It'll also digipeat if you want, but it's better to use the node feature if you can. And it's listing on 2 meters, 147.575. So from this node here, you can get to Rod up on the Central Coast. He's got a port on that same frequency. You can get over to Gerard in Castle Hill. on that same frequency. You can get down to this. This is a node down south somewhere. Robertson, is it? So this is basically a little solar-powered setup, and I think unfortunately at the moment it's deaf. I suspect the lightning strike might have taken out the receiver, so it's still transmitting. I can hear packets from it, or at least I should say VK2RQ can hear packets from it. But if you try to connect to it, and even from my home I can sometimes get to it, but yeah, we don't get any response from it at all. So that's what makes me think it's transmitting, but it's not receiving, so it looks like it's gone deaf. This is my station at home, so I'm running a node, BBS. I've also got a chat server and some other things as well, but these are the two main things. And I've got one of these wormholes up to Rod's place. I've also got some wormholes going overseas, which Rod does as well, to give us some international connectivity as well. So I can get to Rod either through this wormhole, or I can go via VK2RQ, or I can use MB-7 to get to VK2RQ. So by putting this station in here, it's actually managed to link up a lot of the stations around Sydney. So it's a very useful node to have.
Any reason the RAG regenerators on 70 centimetre? Is most of the packets on 2 metre?
I don't know the details of that site, but I think on the same site they will have 2 metre services as well. Maybe maybe it's easier to get a wider separation in 70 centimetres than 2 metres. You need to be a bit. I think it's quite a busy site RF-wise, so it may just be that 70 centimetres was
where they can put it.
Was a better fit for them. And yeah, so from the Gerard system, you can get to Rod's system through this data generator. I think they're the main two guys that use that. But obviously, anyone. I think even from my place, I can actually access that. But I normally sit on 2 metres. The other thing is that both myself and Gerard, we have ports listening on HF, and so that's the frequency that we monitor on. And also Gerard and I both do this bit of a trick, because we're not using physical TNCs, we're using software ones. We can actually get it to decode multiple tones within the passband of the radio. So by setting our radio to that, putting it on lower sideband, we can actually this frequency I've quoted here is not the one you would use. You would use 7037.17 if you're going to use standard tones like out of one of those TNCs. This is the dial frequency on my radio. I just typed it in without thinking, but because I've actually not listening to the standard tones, I've shifted them a bit, so I can pick up the APRS 40 metre channel as well as the packet stuff that's happening. So I need to correct that on the side. Yeah, but what it means is that you know, we can talk to these other guys on 40 metres, and guys like Trevor. What's happened to Trevor is
he just got. He got a bit of criticism from a couple of us because we felt he was off frequency, and he sort of spat the dump. But we're trying to get him back on again.
Well, hopefully
He just hasn't drifted right off.
Incidentally, that's 7036.37 we got there. On mine I use 7037.690.
Right. Okay. So it all depends on the specific tones that the TNC uses. So if you use a 1600, 1800 hertz tone, then 7037.17 is right. But if you're using a different brand of TNC which uses different tones, you need to tune up a little bit more.
What is it, 2125 to 2225 or something like that?
One of the good things about packet is that it's not sensitive to the sideband, so upper sideband, lower sideband doesn't matter. As opposed to something like radio teletype where if you get it upside down, you get garbage on the screen. But the way packet's defined, it'll work on either sideband.
But on that note, if you're a user, like you're driving around with HF on 7 meg, are you always just using 7036? Or how do you know what receiving stations are on iGames?
So it's got to be by prior agreement, I guess, from a practical perspective, or you tune around and you hear some packet and then you tune it in. And so it's basically how you tune it in. You've got to make sure the frequencies coming out of your radio match the frequencies in your TNC or on your computer. So you don't really care what the other guy has on his radio. What's important is that the audio coming out of your radio matches your TNC.
You should be announcing your center CF center frequency, isn't it? Yeah.
That would be
not dial, just the CF.
That would be another way to quote. It's a lot of military types and that tend to quote.
When I went to Queensland, I was getting into about 3 or 4 different 7 meg gates. But now there's probably more out there that I didn't know about. But how am I meant to know who's got what?
So if it's APRS, then there is an agreed frequency which is 7036.
Right.
And when I say 7036, that is assuming certain standard tones. If using different tones, you obviously need to retune your radio a bit to match. So I guess that makes packet on HF a little bit more challenging because you need to get that tuning fairly accurately. You want to be within sort of 50 hertz or so.
Or even closer.
So the software TNCs that run on the PC, they tend to be a bit more forgiving than these hardware ones. But it's the tuning's quite critical. Whereas on the VHF, UHF, you're generally doing AFSK over FM, and so there's no real tuning issue there. If you mistune the radio slightly, it's still going to be the same coming out of the speaker.
Have you tried more than one packet program, and if so, which one have you found the best for you?
Okay, so there are a number of different programs. The two things about my station are, first of all, I don't have Windows at home, so I'm using a Linux for mine. And so Linux has a certain amount of packet support built in. And it's a good platform to play around with because you've got all the source code available. You can tweak it and make changes if you want. So if you're really interested in delving down into the nuts and bolts, then something like Linux is quite good. The other thing is I'm also running things like bulletin boards, which are a little bit, I guess, advanced. So there is a simpler form of a bulletin board called a personal mailbox, a PMS. And so often these TNCs will have something like that built in. And so it's like a little mini bulletin board that is just, it's just meant to support one user. And so people can log in to that mailbox and leave a message. Whereas a bulletin board, you can do the same thing, but it's able to support a lot more users. So there's different BBS programs you can use. Again, I use some open source, or actually it's not open source, but it's freeware.
While we're up along this link of ours, we pretty well go for a packet, the one written up by the chap up at Port Macquarie.
Right. Yeah.
We pretty well stick to that. The other one is WinPack, of course, that you get from England.
It also depends whether you're using a hardware TNC or not. If you're using a hardware TNC, you can really use any serial terminal program. But there are certain programs, serial terminal programs, that are specifically optimised for doing packet stuff. And this Packet, P-A-K-E-T, is one example of that. So it's a serial terminal program that hooks into the TNC, but it will
got a lot of very good features.
It's a bit aware of the sort of text that's going over the channel, so it can present things a bit more nicely on the screen. If you're using a purely built-in software TNC, there's a couple of options there as well, but I think we're probably starting to run short of time. So So if anyone's interested in getting into the packet, maybe come and talk to me a bit later. I can find out a bit about your station and make some suggestions what would be some good options.
If I can get a TNC, yeah.
So if you want to really delve down into this networking stuff, there's a lot of other more advanced topics. We can run IP protocol, internet protocol over AX25, and we can also, that's sort of the reverse of what we were talking before, where we're running AX25 on top of IP. Or you could run IP on top of AX25 on top of UDP. So you can mix and match these things in a lot of ways, and really the limit's just your imagination. So again, we've run out of time, so I won't really go into any of these topics now, but one place you can get some information is a lot of the research I've done. If I found an interesting link, I'll put it on this webpage. So if you want to have a look there, you might find some interesting resources.
Thank you very much.
Thanks very much. Do you have enough gear to do a demo?
I can do a demo, so I don't know if that would be of interest to everyone. But
who wants to see a demo?
Yeah. Go.
Okay. So what we have here is I've logged into my packet system at home, which, as I've said, was a Linux machine. And so I've got two windows up here at the moment. This one here is basically monitoring all the ports, all the packet ports on my Linux machine at home, and printing them up in a user-readable form. So here you can see we've got this VK2RQ, that's Gerard, over at Castle Hill, and VK2NA. He's another guy I've spoken to a couple of times. I think he's into the satellite work as well. So he's connected to VK2RQ. That's VK2RQ-1. That's Gerard's NetROM node. So he's probably connected to that, and from that he's probably going over an internet wormhole to a chat server. I think there's this guy over in the UK he often talks to, so I suspect that's what's happening, and so you can pick up little snippets here and there, packets going forth, and so you've got the call signs, the control fields, and the sequence numbers and things, but you can then see the text, so you can overhear what's going on.
I don't know if you've noticed, but NA was started beaconing. He's doing his beacon via Leaf lately. I don't know why.
Oh, okay. He's using Digiped. Yeah, it's probably limited usefulness. Both Gerard and I think Rod as well, if we hear any packet on any of the frequencies we listen to that is formatted like an APRS packet, then we will decode it and actually put it up on the APRS network as well. So if this guy was to beacon, you can see obviously I can hear him, so if he sends a beacon, it will end up on the internet. Okay, here we have, this is one of those announcements where we've got a node here, which is, the node here actually just sent out a packet, which describes all the different places it can reach with the quality and the path it's got to take. So those messages get broadcast out at regular intervals, maybe every 20 minutes or so. So what I can do on the other side is I can actually connect to something.
How are you accessing that over there?
Just using internet over an iPhone. Back to, it's actually going via the Internet in California, and then so all right. What will we connect to? So the first thing I can do, so on Linux you type a command, you've got to say what port you want to use. So I want to connect over an internal port that I've got that will connect to my own node. Well, no, let me connect to the club one here. So I'll go over my VHF port, which is SN1.
Is that going to work?
So that's my 2 metre port at home, so it should come in and it'll be VK2NB-7. Okay, so it's connected. Message is probably scrolled up off the screen.
That's
so
right there, down the bottom, you can see it.
I can see it?
Yeah.
Oh, okay.
Yeah.
So what I'll do is I'll type nodes. This will list all the different nodes that VK2NB-7 knows about. And there's not too many. All the nodes here start with RQ. They're belonging to me. So you can see the call sign and SSID. And this is just a user-friendly alias. So you can see that's my BBS, that's the chat, that's the node, and that's another node. So I'm actually running a couple of different types of software just to experiment. And there's also a DX cluster. So let's find out how it's finding out about that DX cluster. So I'm going to go node DXC. Okay, and there's 2 possible paths to get to it. You can either go via ROD, VK2DOT-1, or via my own node. So as I mentioned, both of us have internet connectivity and these wormholes that go to the global packet network. All right. So let's connect to a chat. One of the things that we should see nodes from Rod's station. He normally advertises a lot more, but I haven't seen any today. So that makes me wonder whether there's a problem with Rod's 2 metre port. So I could get into his station via a different path, yeah, he's not appearing there. And the VK2AMW-7, that's the one down south. So you can see the station here is hearing it, but if you try to connect to it, it doesn't work. So what I might do is I might connect over to Gerard in Castle Hill. Maybe hear the relay clicking in the shack there. So we're connected to Gerard's station. Let's find out what ports he's got on his node. So these are the different ports he's got connected. He's got some internal port, whatever that is. He's got port 2. That's the frequency that we're on now, that I'm accessing him through. He's got this other backup one, port 4. I don't think he uses that much anymore. Port 6 is that data generator up on the Central Coast. And port 7 is that's a higher speed link, a 4800 baud modem, which I think he's got shut down at the moment. That's not actually working. But the port 6 up on the Central Coast, we should be able to connect to Rod via that. So what I'm going to do is I'm going to connect to, using port 6, to VK2DOT-8, for example. So that's Rod's chat server.
And this is because they're NetROM, you can sort of go from one to the next to the next, is that
That's right, yeah. Right. So you connect to one and then you can go to the next one. Or if you connect to one node and you want to connect to some other node that you don't know how to get to, you just use the remote station's call sign, and NetROM will, it will set up the routing table so you will hopefully get there. Now what's happened here?
You haven't put a number.
I finished typing.
Stop.
Okay, I probably lost my internet connection or something dodgy's happened.
Demo gods.
Demo gods.
Well, as soon as he says, watch this.
Mm-hmm.
Alright, so we'll try and that's
the Linux version of boot for
There you go.
screen of death.
Oh, good.
Come good.
You hear the relay clicking some more. So what will have happened is while we'll send the connect request to Gerard's system, then Gerard's system would then be sending the connect request up to Rod, but it'll be sending it on the data regenerator input frequency. So Summersby will then retransmit it to Rod.
too. Is this all just a scam to make ACMA think we're using all the frequencies?
Alright, so this looks like my I think it's a Telstra. Telstra's the weak link on this.
Your relay's going ballistic.
Okay, well, what I'll do is I'll just connect a little bit more reliably. Cool. So I'm going to use NetROM on my system. So I don't know how to get to Rod. It'll work out the best way. VK2RQ-8, which is his chat server. So it finds some path, whether it's through VK2RQ-7 or it's through some wormhole through the internet. It somehow manages to arrive there. So again, you can see there's only one user here, which is a bit disappointing. So what I can do is I can do a /w who to find out who's connected. I can join another channel if I want. But there's not much here. What I can also maybe try and do.
What about looking at the DX clusters or something like that? There's always something going on.
Okay, we can try that. Okay, so I'll connect to my own node locally. Let's find out what nodes I know about. So you can see I know quite a few. Which you learnt through.
It's the equivalent of having 500 people connected on LinkedIn.
So I need to find a DX cluster.
Yeah, there it is.
So there's a DXC one there, or a DXCC. So there's a number of different ones.
MIA.
Yes, you can see really from there's call signs there from all around the world. There's quite a few from the US, from Canada. There's not so many in Germany because they tend not to run NetROM so much. There are a couple of competing systems. One's called Rose. We used to run here in Sydney, but it's sort of disappeared now. And another one's called FlexNet, which is it's a bit more sophisticated the way it manages the use of the channel, and so it uses some methods where you sort of get permission to use the channel and then transmit. So it's developed in Germany.
I hold the conch.
So I think it'd be interesting to try and set it up just for fun. But it's not really used much in Australia. So NetROM is sort of the common standard that most people support.
I had a look at FlexNet. The internet didn't know what they were talking about.
Yeah, it'd be a bit complicated to set up. So here I connected to this Canadian DX cluster. So
when you connect to it, you're just going to see anything that goes.
You will,
out,
yeah.
Out on the cluster.
So we should start seeing some spots pretty soon. Maybe the bands are closed.
Never.
Winter at the moment over there.
How many lines do you get when you go to the cluster on this thing? I remember it was only about 10-15 about, and then you couldn't get any more. That's 15 years ago.
Oh, this one, yeah, now you can stay
It
connected.
goes forever.
Yeah, it goes forever now. Which if you're operating over the RF channel is maybe not very friendly, if you're not actively using it. Yeah, like I said, most connections to these DX clusters these days tend to be over the internet rather than via an RF link. But the packet over the RF link does still work. Alright, so there's not much happened at wind bands at all.
We're not letting the sunrise over in there.
Let's see if I can find a different chat server that may have some more activity on it. What is it? N9 PMO. The guy's Mike over in the US, he probably has a bit more. So it'd be PMO chat, that's what it would be. So I'll disconnect from the DX cluster because there's no DX.
How do you know we were connected to it?
Because it said.
Yeah, it said hello, Matt.
Now you just say.
So it said hello, Matt. So welcome to Tom's DX cluster. So PMO chat was the alias, I think. So it's using NetROM. So I don't know how to get to that guy. I don't have a direct wormhole to him, but maybe it goes via a rod system who somehow connects. So this is another chat server. Is there anyone on? Invalid command.
/H.
/U.
Yeah. Oh, show users. So /U, not /W.
What?
Just me. What time is it in the US? It's
Very
Oh, the midnight. Well,
okay.
very early in the morning.
Just sleeping. Well, this guy VK2NA was probably connected to a chat server somewhere. That would have been in the UK, so maybe that's open. So we had a look at the UK one. We could maybe have a look. All right, so this demonstration's not going terribly well.
We'll put some scary music behind it, so it'll be more.
No, that's the entertaining part, really.
Okay. I'll show you the bulletin board and all the worldwide bulletins that. Okay, so it's dumped me back into Mike's node, so I'll disconnect from his node.
B for buy, is it?
Yes, generally. VK2RQ-2. Okay. Cool. I'll use my local VK2RQ-2. Is my VBS not working? Okay.
Quick, ring your mum, get a reboot.
Okay, I'll connect to rods then. Okay, 2DX.
Nope.
Nope.
Okay. Oh, I've got one message I haven't read from VK2ACL.
Careful
right.
now.
I'll
Bring home your milk.
use L for list, so that will show me all the bulletins that haven't been read. So first, you can see here we have, you address it to either a call sign or to like a general topic. The B means it's a public bulletin, the P means it's a private message. So, well, we have looked at here, let's see what so I'm going to report listing.
God, ASCII graphics now.
Oh, you like ASCII graphics, do you?
That's old Thomas too, isn't it?
Okay, so we've got some jokes. Oh, that shouldn't hit enter. So here you can see the path that it's taken. So VK2DAT is where I'm reading it, but it's actually come via these different. So it actually originated in the UK, went to Canada, Italy. Where's he?
Somewhere in Spain.
Spain, and then to Rod, and then I'm reading it on the God system. So sometimes it's interesting to have a look at that. Dom said ASCII graphics. There's a guy here who posts these technical articles, and he does all the circuit diagrams and everything using ASCII art, which is quite interesting. I'll see if I can find one of these. Here we go.
Hands a spotlight and a graph in it.
20835.
835.
And you could harness that genius for good, not evil.
ASCII.
That's a hell of a drug.
Yeah.
You can actually share files as well, binary files. So there's this Japanese guy, for example, who his hobby is obviously taking pictures of flowers, and so he'll send all sorts of these binary. Okay, so here we have some technical graph. dBm, loud car noise is 0 dBm. Bully voice. Okay, this is a frequency response, I see. He's talking about the frequency response of his microphone, 300 hertz.
There's an ASCII version of Star Wars on the internet. Maybe you can contribute that.
Alright, so this is his high-tech headset by Woodland.
Oh, I'm glad it's got text on it too. It's a story better than Herald today.
Oh, really?
Some poor bloke had a bike accident for weeks on end.
Oh. How do you explain that?
Okay. The other thing is, of course, we can access all this packet stuff equally well from the Shack PC via the packet station we've got there. So you just start up a terminal program. I normally use PuTTY on that machine, and then I think you have to hit escape to get it to go. C for connect next to the TNC, and then you just go. You can.
And that doesn't disrupt the operation of the NetROM functionality?
No, it's completely
okay. Going in through
they work together.
Cool.
The only problem is in the Shack that the serial cable I've got that goes to the computer, when the computer's turned off, it actually pulls one of the lines low that caused the TNC to lock up after a while. The buffer fills up and then it locks up. So I actually need to modify the cable so it only does the transmit receive grounds, doesn't do the handshake lines. That seems to be causing some problems. So normally we unplug the TNC in the Shack when we're not here. But I'll have to get a cable made up or an adapter made up so that we can avoid that. Yeah, that's right. So because they've got more wires, they cause the TNC to start buffering things, and when the buffer fills up, it locks up, doesn't respond anymore. All right, so
that's cool. Thanks so much.
Thanks so much.